tutorial explains how to do a qualitative analysis using linear retention index. To start, we have to record an N-alkane standard, and this N-alkane standard is loaded here, and we have to do quantitative identification of this standard. So in other words, the names of the individual alkanes should be given like C and their corresponding carbon number. This is important for later identification and automatic calculation of linear retention index. Second thing, results have to be there, so integration must be done. If that is the case, we can load a corresponding file which we would like to use the identification with linear retention index. So we work on this data file as a pesticide file, and we go for qualitative parameters, and we define the pesticide library which contains linear retention indices, and we go for retention index, and we open up load from file, and here we load the alkane mixture with a 30-meter column, and we open this up. During opening this file in this table, automatically the retention index is calculated by multiplying the name number with 100. So this makes the calibration of the linear retention index. The second thing is we define similarity search. We define a minimum of similarity, and first I would like to make a standard identification without linear retention index, so we press OK. We go for qualitative analysis. We do peak integration for all TICs. We define slope, and we do integration, average from start to end, calculate from peak. We do averaging too, and we got the corresponding results. We check the qualitative table, and we can double check and see the corresponding compounds here. So we have a similarity index bigger than 75. These kind of hits are indicated here. In some cases there is only one, in other cases there are more than one. We do the same checking the NIST library. With the NIST library, we see now the result, and there are a lot more possibilities with similarities bigger than 75 for several compounds. In this case there are only two. But what we nicely see, there are two, but with two totally different retention indices. First of all, when we load the calibration of linear retention index, each cursor position has a unified retention index seen in the spectrum window. So now we have a calibration, and we can add linear retention index filtering by activating retention index allowance. This function specifies that a retention index of a peak is calculated like this one. This is a target, and it's compared to the library entry within plus minus 10 units. So in activating this, we make a peak integration again, And what we see here, there is actually no result with the retention time, the retention index similarity in the NIST library. In other words, similarity index bigger than 75 and a linear retention index within that window doesn't lead to the identification in the NIST library. Now we do the same with the Shimadzu pesticide library. We press OK, we do the qualitative integration, and we see directly there are identifications using the NIST pesticide, the Shimadzu EI pesticide library. So in double clicking here, we see now the result here is similarity index is 96. The retention index of the substance is 1261, and the retention index in the library is 1258, which obviously is within the ±10 window. The same for the other compounds. Here the calculated retention index of that peak is 1758, and the library says 1757, so very precise. This is a good example, while very often Shimadzu libraries are more precise when using linear retention index, because commercial libraries like NIST does have lots of entries and the experimental conditions are not always clear.